Okay, so thank you everyone for being here for the third session on data reuse. So earlier today we've had two other sessions with a focus on overcoming barriers or perceived barriers to the reuse of research data. So we have been talking about cultural and educational aspects. We have been talking about technical and legal aspects, and now we are turning to the third and final session that is on technical aspects. And just to repeat what Anya said, this meeting will be recorded, and you will find all the material online a bit later this week or next week. Um, so yes, so we have been talking a bit earlier today about the importance of that sharing data, reusing data might encourage the enhancement of transparency of research and also by this the reproducibility of research. And we have also seen that what is very important when it comes to reusing data is that data are equipped with metadata, that they are equipped with other documentation, and that this documentation and metadata are of a certain quality. And we also seen that making data reusable is perceived as an obstacle by many researchers. So working to improve the metadata and documentation that come with published research data is of very high importance. Another factor that is important for the transparency of research is our data citations, and we just heard about that just before the break. Measures taken to improve practices in the communities that the researchers cite the data, and that repositories make it easy for researchers to cite data. And of course, data citations are not only to make research transparent, but it's also a tool that can be used to evaluate the reuse or the impact of your data. So we're going to dig into these aspects a bit deeper in this final session, but just before we start, again, a few words about the Fidelis project. So we who organized this event are all associated with the EU-funded Fidelis project. It's a project that aims to establish and operate a network of European trustworthy digital repositories. It started in January last year, and it will end in December next year in 2027. It's a project that is led by CSC in Finland, and it brings together 25 partners representing national level and discipline-specific repositories from across Europe. And in addition to establishing a network of TDRs or trustworthy digital repositories, the project aims to build capacity among repository staff. So we provide access to hands-on training, we have mentoring programs, and we have these free open training sessions where everybody can attend. And you can learn more about the project by clicking on the links that we will share in the end of this presentation. So this is the program for this afternoon. And it's for those of you who attended before the break, it's more or less the same structure. We will have 3 presentations, each with some minutes for questions and discussions afterwards. And there will also be a short break before the final one. And of course, as always, you are more than welcome to share any comments or questions in the chat while the speakers are presenting. So I'm pleased to welcome the first speaker of this session. So Svein Høyer, is a senior research librarian at the University Library of NTNU, so the Norwegian University of Science and Technology, where he contributes to the implementation of the institutional policy for open science. His area of work is research data management, from planning and collecting to curation, archiving and publishing open data. And he is also a project member of EOSC Eden, which is the sister project to Fidelis. So, Svein, the floor is yours, and I will stop sharing.
Thank you. Just give me a minute. Okay, I think it's okay now. So thank you for this opportunity to talk about this topic under the mentioned title, the complexity of metadata completeness and why it is essential to sound reuse of data. And in this session, I will start by talking a little bit about the last part of the title and saying something about why optimized metadata is essential to sound reuse of data. And then I will try to dive into the complexity of what can be called metadata completeness. Together, we will also do some guided browsing, so to say, through some metadata catalogs and information during this session, taking the perspective of a metadata consumer. And I must say that since the format today is not that many minutes, I will take the liberty of simplifying what is indeed quite complex matters. I hope to give some sort of an overview of some of the things that continuously should be worked on and improved with the goal of reaching metadata completeness. So in this session, we will try to see metadata from the perspective of the designated communities and the metadata consumers. On the right side here in this figure, landed from the Open Archive Information Systems reference model. This choice of perspective hopefully resonates with user focus, even if metadata producers also can be referred to as users in the case of archives and repositories. And for those of us who perhaps mostly thinks about the production side and the management side of metadata, I think it is fruitful to see metadata from the receiving end in this model and try to be in the shoes of the metadata consumer. So, why is metadata essential to sound reuse of data? When answering that, we have the FAIR principles to refer to, of course, and the more well-known important FAIR aspects connected to metadata and metadata schemas like findability, accessibility, interoperability, and reusability. At the same time, these 4 keywords can perhaps also be supplemented with some other process-oriented keywords like added in this slide. If trying to seeing the big picture, one can say that the ability to reuse data is heavily dependent on a combination of the user's prior knowledge and skills, like domain expertise, understanding of methods, analytical skills, knowing facts, concepts, being experienced within the relevant field or topic, combined with access to metadata. So high quality metadata act as a bridge that allows someone other than the original creator to interpret, trust, and repurpose data. That's also important. A user's prior knowledge determines their capacity to effectively utilize that information. Some relevant processes that can be mentioned. Metadata is important when identifying possible data for use, like when searching, discovering, finding. Metadata is important when comparing a large number of identified datasets, like when browsing, filtering, excluding, and selecting. Metadata is important when evaluating specific datasets and the connected files for possible reuse, like accessing, opening, evaluating. Metadata is important when making meaning out of the data as information. So when contextualizing and transforming data into information, so to say. Metadata is important when reprocessing, reanalyzing, and resynthesizing information, as well as actually reusing data. And in the end, using it either to verify knowledge or prove assumptions wrong or gain new knowledge. So one could say that metadata completeness is possible to measure by using various degrees of compliance with the FAIR principles. That will be one way to measure such completeness. But one can also say that metadata completeness often can be even more complex to measure because it is context dependent, connected also to the topics or disciplines the knowledgeable and skilled reuser work within, as well as the different knowledge level of the reuser. Discipline-specific schemas provides a richer and more targeted structure and can include vocabularies that allows detailed information to be provided, but measuring different levels of richness as level of completeness can be a more complex task. Also, adding to complexity, what kind of units do archives and repositories offer metadata for, or seen from the perspective of the metadata consumer? What does the end user meet in the form of available metadata? Answering such questions, it will be relevant to talk about different granularity levels of metadata that all can be regarded as useful metadata by both repositories and archives, as well as the designated communities. Beginning at the top, metadata can be federated into catalogs as well as be on the repository or the archive level, or if you like, on the data source level, informing the world about one or many repositories and the data or inventory within them. Reta3data.org can perhaps function as one combined example. In some cases, metadata can also be connected to a collection and be on a collection level, sometimes also referred to as the community level. The dataset level will be important to many of us, of course, and the level where most of us do our work or spend our time. But metadata can obviously also be on the object or file level, and then could be embedded or be intrinsic or file internal metadata inside an object or file. And important functionality connected to this granularity level is also the extraction of file internal metadata and the embedding of external metadata into a file. The point here is not to present a complete list of granularity levels, but hopefully to give some sort of overview of different relevant levels. I think we also need to remind ourselves of the complexity at hand when discussing metadata completeness within or across different granularity levels. Seen from the perspective of a repository, these different levels can also be strategic areas to either put manual and automated efforts into or not. So let's all do a little bit of browsing. And the metadata check number 1. I would like to ask you to, have you put in the links, Helena? Yes?
Yes.
You can use one of the link number 1 in the chat. And just check whether you find the repository that is most relevant to you in the registry of read3data.org. And the reason I'm asking for this easy exercise is of course also that it's relevant for all repositories to have a record within read3data.org. And then please just check quickly if you're not familiar with with this registry already. Most of you are probably already that, but please check what kind of repository level metadata that is present in this registry. Also, it's not surprising, but it can be useful to check the numbers of the different metadata schemas and standards used by the different repositories in re3 data. So my question here is, what is the 5 most used metadata schemas standards? So just do an empty search and you will find 3,700 something repositories, and you'll get the numbers on the left-hand side, if I remember this correctly, under metadata standards. If this leads to some surprises, please comment it in the chat. If you do not find a repository that is relevant for you, you can always suggest a new listing. See the top right in the user interface. And I would like to mention that within the Eden project, the sister project of Fidelis, we have been discussing how richer information on the repository level can be improved and provided in registries similar to re3 data and others. I hope that most of you will find your repository in this registry, and hopefully you can have a look at the most used metadata schemas. If not now, maybe later. My main point of bringing this up or doing this is what a very simple mapping can tell us. For instance, the use of the more discipline agnostic schemas versus the more discipline specific schemas when it comes to metadata. Okay, I'll have to move on. We can have a look at some other examples of how the different granularity levels of metadata can be relevant and used in different ways. So as mentioned, re3data.org can be one relevant example, a registry that has defined, do use their own metadata schema. Another example of a federated catalog can be Data Europa EU, and they use DCAT-AP metadata standard. This catalog is mostly for open public data more than research data, but it's still interesting to look into. Similar, one can find a minimum set of metadata for a collection, like defined in the case of the Zenodo community called EU Open Research Repository. And some will inform the metadata consumer of metadata quality on the dataset level, like in the forms of metadata metrics used at the mentioned Data Europa EU. We will also find many examples of how metadata on file level and file internal level will be connected to file formats and standards at file level granularities. So let us do a metadata check number 2. I would like to ask you to find out whether you find data from your own institution or / your own country in the EU Open Research Repository. And if so, is it much of it? Is it many dataset or not, or a few? So please use the link number 3 and look up the most relevant datasets in your case. It can also be interesting to have a look at what is the defined as the minimum requirements when it comes to metadata in this collection in Zenodo. So use link number 4. This will lead to the creation policy, and not on the top, but further down, you will find listed the minimum requirements of metadata. As you will see, there is a set of minimum metadata requirements, and one can talk about metadata completeness within this kind of framework, which is, of course, a minimum set, but it's also relevant to talk about completeness within such a short list or small schema, so to say. Okay. So moving on also to technical complexity, one can ask, in what technical ways will metadata be made accessible for discovery and use? That again can lead to the reuse of data. One important starting point should be that a repository should manage the primary authoritative metadata for a specific item, let us say a dataset. Usually this primary authoritative metadata will be made searchable internally or locally, as well as presented in the form of landing pages, often with download links. We all know this probably. And it is and very important for reproducibility and reuse of data. One point that must be considered is that items should also be citable, like mentioned earlier today, and have a persistent identifier that can be used in articles, in code repositories, and within research results, other places and other solutions and systems. This because one very reasonable way to think that people end up in a landing page and end up reusing data is publications and other research results. Most of the time, the same authoritative metadata will be made accessible over APIs and made accessible by being possible to crawl, harvest, possible to index by machines. And then the same metadata again can be included in federated and searchable data catalogs, or perhaps mirrored in registries and similar. So technically, one can say that the flow of metadata will be really complex. And in most cases, it will be relevant to talk about where a single source of truth will be located when it comes to metadata, and how possible changes in such a record will be propagated or distributed to other systems. The different connection points between the system can also call for interoperability, of course, and crosswalks between different kinds of schemas when it comes to metadata. This is also aspects that are being worked on within the Eden project. Okay, let's do metadata check number 3. What level of metadata qualities will be measured for the EU Open Research Repository in Data Europe EU? If you do not find this as the most relevant, you can of course check dataset metrics that feels more relevant for you. My point here being that we can check for the metrics on metadata quality within Data Europe EU. And it can be discussed if this is a good practice, something that more catalogs and repositories should do, or should it be done in a different way, or could it be a starting point, things like that. So on the left-hand side, you will find the metadata quality as one of the things that you can filter when you search for data and data sets within this solution. And they also have some metrics on the higher levels when it comes to metadata granularity levels. So one can look into how this way of measuring, how this mechanisms of metrics works on different levels. Again, if you find something surprising, please add it to the chat. If you have a comment or question connected to this, I'm not sure I'm the best one to answer, but please paste it into the chat, and we will try to use it as a basis for discussion if time permits. So, summing up, metadata completeness is complex because it can refer to a number of different things. It can refer to the act of providing or the provision of rich metadata to the competent reuser. could refer to how one facilitates reuse for many disciplines with one generic schema, the challenges connected to that, meeting the needs of machines as well as people, providing only the minimal or the core metadata that enable federation, providing metadata within one, many, or all of the granularity levels, implementing the many available ways, technical ways of giving access to metadata, and measurement or metrics connected to completeness will often also be similar complex. Ways forward can be the traditional ways of working when it comes to community watch and technology watch, and combination of these two. So what I hope to kind of do here is put you in the shoes of the metadata consumer and try to think around how the systems and interfaces and ways of providing metadata will be important to the metadata consumers when they choose or to reuse or not data that has relevance for them. Okay, I think that's it. So we should continue this discussion, of course, when possible. So maybe if we have a little time now, we can have a brief discussion.
Thank you very much, Svein. That was a very useful overview, and thank you for walking us through the complexity of the metadata world. Do we have any? Well, the mic is open. Anyone wishes to be the first one to, well, share any thoughts or comments or questions with the rest of the group? Yes, Alan?
Yes, hi. Thanks for this presentation. It was very interesting, like eye-opening when you see all the metadata standards used on re3 data, within these repositories. And I was also checking, I mean, plenty of these, when you list, for example, any of CESDA repositories, we use DDI as a standard in our community for social science datasets. But every repository also has by default, Dublin core and some standard formats available. So this is also counted there. Anyway, I saw you put there also like one generic schema as a help of to integrate cross-disciplinary, maybe cross-domain, etc. I mean, of course, we know that this is not possible, but I don't know if you are aware of two things. One is CDIF, so cross-domain interoperability framework, and the other is DDI CDI. So it's a DDI like a format. CDI is cross-domain integration. So it's the variable metadata on a variable level metadata described. So cross-domain integration framework CDIF is let's say set of domain agnostic common elements, which on the higher level describes the identifiers, agents, provenance, distribution, licenses, etc. And then you have any other metadata schema and data sets can be represented in domain specific schemas that are used by default in some some specific communities. So this is CDF is some kind of glue between this high level description and specific schemas that are used in certain certain disciplines. And of course, this is something, this relatively new thing. And I don't know, are you aware of that? And what do you think about this? Because I don't think that one generic schema is possible, you know, to develop and to embrace within all disciplines. Yeah, thanks.
I'm not really aware of it. I would say that, in my opinion, there's been different initiatives that in this direction, right? So it's as a strategy, it's interesting to think that well, a minimum set could give some possibilities for interoperability, right? But also a maximum set will give some possibilities, but then you will need to think in different ways when it comes to crosswalks or those kind of solutions. Maybe my time is up, Helena. Is that
we still
right,
have
or?
3 more minutes if
Okay. Maybe
yes.
some others would like to comment on the points made by Alan. Okay, then.
Well, just then I have a question.
Yeah.
Well, it's kind of it's perhaps another in another area, but so, and this is more for the kind of the user end user perspective. So we are teaching a lot these early career researchers in how can I say it, the introducing them to research data management and data stewardship, and of course metadata is one of the key elements on the material. But and of course, so my question is how what should we expect from researchers when it comes to, because as you say, I mean, when you start going into the whole discussion of metadata completeness, it's rather complex. So my question is, so how much should we expect from a researcher, which is kind of which is supposed to, well, learn about research data and research data management and sharing. So what should we expect from a researcher when it comes to knowledge about metadata and metadata completeness? Perhaps that's my question.
It's a
and
difficult question to answer,
I
but
know,
I think one way of discussing with researchers could be to precisely put them in the shoes of the reuser. So and remind them that the reuser might be you, right? So after some years, what would I appreciate of my, or how would I organize my data for the future, for my future self, or for my colleague in the future, and then maybe we can hope for some kind of motivation for actually going into this this field and learning about it, and also hope for some completeness when it comes to filling in metadata or creating it.
Yes. Great. Well, thank you. If there aren't any other questions or comments, you can always drop them in the chat afterwards. Then well, thank you, Svein, for giving this very interesting presentation. And I guess you will stay in the room until the end. And then we will turn to our next speakers, who are also located in Norway. So I would like to welcome Dag Even Thorsø and Ali Abdurrahman Khalil, who are working at the University of Southeastern Norway. So Dag Even is a senior librarian at the University Library, where he leads the institutional research data support group. And Ali is a senior academic librarian in the same university library and is also part of the institutional research data support group. And they are going to talk about a tool that I have created at the university, the famous universal README generator named Urge. So the floor is yours.
Thank you. I'm a bit, I've just gotten a new computer screen, so I'm not sure what I'm sharing now. Are you seeing my notes and everything that you're not supposed to see now, or are you seeing just my PowerPoint?
We see your PowerPoint, but it's kind of, and on my side, it's a bit small, but I can still read it. I don't know how
Okay,
it's.
yeah, I have some issues with that. Haven't figured it out yet, but of course,
Yeah.
you will get this presentation later, so you can.
I think it's okay. Yeah.
Great, thank
Yeah.
you. Okay, so nice to be here. And it's fun to be here because we are here to talk about a document that has gone from being kind of a complicated obstacle for us to something, I actually dare to say, to something fun and something motivating to work with, a fun working task. For us, that works with research data at USN, the University of Southeastern Norway. Of course, you know what I'm talking about. I'm talking about the README file. But we're not only talking about the README file itself, because as Helena mentioned, we are here to talk about the new tool that we have developed to generate good README files. And that tool is called Urge, Universal README Generator. Of course, we all know, at least all in this digital room, know what a README file is. It's usually a text file that introduces and describes the content of a dataset. It typically describes the background, the context, the collection, and the generating of the research data, information about the methodology used, about the different data files, and hopefully much of the information needed for other researchers and other end users to reuse the data material that it describes. Yeah, looks like this. Yeah, general information, methodological, oh, difficult word, methodological information, data-specific information,
Yep.
and more, of course. So there's no doubt that the importance of a good README file, it is a key document, a key tool to kind of fulfill the FAIR principles. But it's our opinion that the traditional way of creating README files with this template, TXT format template, it's not very user-friendly. You know, help texts must be deleted manually. Irrelevant fields must be deleted manually. It's not as intuitive to the end user. It's not machine readable. It has some challenges to it. I'm pretty sure we all have been there trying to understand a README file, and it doesn't make as good sense as it should. So we wanted to do something with this. Luckily, we have a programmer, and his name is Ahmed Dugan. So we asked him if there was a way of making this easier, like something along the lines of the kind of SICT data management plan template that could make the process of creating a README file more intuitive and more easier, basically. Ahmed, he said yes, and he started to develop what you soon will see the latest version of that we call Urge. Urge, it makes I think the entire process of writing the README file easier. You can import metadata from Dataverse. You can upload text files, JSON files, import information from the SICT DMP template. It has good help text. It has some mandatory fields that you have to complete before being able to generate the README file, and you can import the README directly into Dataverse. So that is a few of the functionalities. But now just let's have a look at it. So I will give the word to my colleague, Ali, so we can take a look at how it looks in real life right now.
Thank you, Dag Evan. Hi, everyone. First of all, thank you to organizer for inviting us to present the Urge solution to you. And now I will take you into the demo and show you how Urge actually works. Let me share first my screen.
Yes.
Yes.
Hope you see my screen. Yes, thank you.
I see it.
Yes, here is Urge, the README generator developed for Dataverse NO. It is designed based on Dataverse NO README templates, which is available on Zenedo. You see it here. Gavin also showed you that. Okay, let us start with the interface. At the top, you find a short information about what Urge is, its main key features, and the benefits it brings to users. And below that, you find one of the most important features of Urge, that is data import, which makes writing README file much faster and easier. As you can see, there are 3 ways of importing information from different sources. The first one is a way of importing information into README generator is called Dataverse metadata import, which allow us to import metadata directly from a draft data set we created in Dataverse or Dataverse NO into the generator. And the second one is SICT DMP imports, which is used if you have created a data management plan using SICT DMP tools. It gives you the opportunity to import the relevant information for the README file. And the third alternative is README imports. This option is useful if we already have an older README file, for example, and want to edit it or edit it and reuse it, or build on it for our new data set. Okay, let us see how we'll take away this. Now let me show you how the README metadata import works. I have created a synthetic data. This is synthetic data, not actual data set, just for this demonstration. As you can see, the data set usually comes with title, description of the data, DOI, and more metadata information, also together with the data files. And as you know, most of this information are important in a README file. So if you want to create a README file for this data set, instead of just entering all this information, title, description, and so on, what Urge does is that it automatically import for us some of the important information for README file, and automatically extract from the data set and import it into the README generator. The only thing we need to do is that we need to copy the API token and also the day of the data set. when you do that, when you copy this and paste it here in the data versus metadata import field, then when you click this option, I have already copied and pasted just to save time. So that urge import the relevant information from the draft data set directly into the generator. For example, now I have urge imported for us the title of the data set, DOI, contact information and description, and also list of data file and the list of data file and together with the size of the data file and the format of the data file. And after that, you just continue. For example, if you have entered information and metadata information, contributor, data type, so on, you just click this and just to retrieve the metadata information, and also just continue if it is relevant, and generate the text that, for example, for this other options, it will lead the reader just to refer to the metadata field in the data set. Okay, this is how we import information with the help of data versus metadata import. Now let us see how we import information from the SIGT DMEP. SIGT DMEP, as you know, is just widely used DMEP tool, at least here in Norway. So if you have created a data management plan for the data set that you want to share, Arge can help you to import the relevant things that you have written in data management directly into the generator. Among other things, as you know, the information we include in the data management plan is just the method used to collect and process the data set. So these are the information we typically describe in a data management plan. So we can import this information with the help of SIGT DMEP import directly into the README generator. For this, to do this, just I have an example DMEP here. First, we need to export the DMEP in JSON format. We need to export and download it, then upload it here. Upload it by clicking this choose file icon here. And I'm interested only at this time, it can import more information than other than methodology also. But at this time, since we have imported information from the draft data set, we just need the method section to be filled out. So I just click fill form with this information. I have uploaded the JSON format of the DMEP just to save time. Then I click select. Then the method used to collect the data set will be in the section that says description of source and method used for collecting, generating data. Okay, once we have imported data from this different source, we continue filling out the remaining field manually using helpful guidance in information box. Just you see here, it comes with information. The Arge comes with each field have their own useful information box, which makes Arge user friendly. And also, as Doug even mentioned, some fields are mandatory to ensure README file meets the necessary standard and is as complete as possible. In addition, Arge offers two quality checking tools. These are a grammar checker. It has a grammar checker that ensures the text is clear and well written, and also a file checker. The file checker checks whether the uploaded files are in preferred file format or in open file format, and whether the file names follow best file naming practice or not. If not, it will give a suggestion. For example, README file is not uploaded. Of course, we are working on it. But as you see here, this file name is very long. It gives a suggestion that it is too long. It's more than 25 character, and it gives a suggestion how one can rewrite the README file. And also the preferred file format suggestion. This is Excel file. It suggests it is recommended to change into comma separated value. and so on. Okay. Once we have completed all the feed, we have different options to generate the README file. We can simply click send to Dataverse and generate a README file in plain text format and send it to the draft dataset. I just click this one and click OK. So if I go to the dataset and click refresh, here is the README file in place with in the dataset. Here is the README file generated by Urge. And also you have the option also to generate a machine readable README file in JSON format file. You can just click here and you can get a machine readable JSON format README file. And also you have the option also to generate anonymous README file, for example, for use in journals that have a double-blind peer review process and your data is part of it. Or you can generate simply standard plain text and download it like this. Okay, finally, I would like to mention that Urge is designed based on Dataverse NO README template, but it can be used for other Dataverse installation as well. This is because, as you have seen before, the core citation metadata that Urge relies on, such as, for example, the title, DOI, contact information, and description, and so on, are standard across all Dataverse systems. So this makes it possible to use it in other Dataverse installation. And the other metadata, as you see, is the data type, geographical location, and funding. These are optional in Dataverse also. So one can just, other Dataverse installation can choose to include them if they have them, or simply skip them as they prefer. In short, this is how Urge is designed and how it works. Thank you for your attention. I think Dagev, do you have something to say, few things to say?
We have received some questions in the chat. Unfortunately, Ahmed is not here. He's on vacation. So there was a question from Jessica if the code for Urge is open source. And at least I know that we have the plans to make it open. We will share it. I'm not sure if it's openly available on a GitHub page now, but this is something that we will be totally, of course, transparent about. I think it is open source, but I'm sorry, I don't have enough technical information to figure it out. Do you remember, Ollie?
I think as you said, he has a plan to make it openly available after getting a suggestion from one of Helena's colleagues from Philip. But I think, yeah, we have to wait until he.
Yes, he will be back next week.
Yeah. Philip, do you want to comment?
For some time, and I think it would be really good to make this open source available, and I guess the global database community would be happy to help you with that.
Yes, definitely. That is it is in our plans as well.
Yeah.
Yes.
But given we are looking not the presentation mode of your slide.
Okay.
Yeah, I see that there are a lot of comments who, well, first of all, congratulate you with this tool, but also are very interested in knowing whether this could be implemented outside of Dataverse, and also let us know when something happens, and we can share that with the wider community. I see that. Well, we have comments also in the chat, but first, Alan.
Yes, thanks. So this is some kind of trying to structure textual data. I mean, what is the benefit of using this? I don't know, instead, or this is like in parallel to using some standard schema, or I don't get the idea behind that.
We had some challenges to explain, to learn how to operate the traditional text file. It was our experience that a lot of, if the fields wasn't filled out, you know, the standard fields in the text files, they were there and they were empty. The help texts in the template were not deleted. So it was our experience that the README file made by the text template was difficult to kind of understand because it had, so we just wanted to make it easier, basically. Of course, a lot of researchers who are familiar with the importance of a good README files do not have the problem. Or if you have kind of a really good infrastructure and really kind of large scale support service that has the opportunity to go through the README files and kind of clean them. Of course, not everybody had that problem, but we definitely had it. So the README files that we received were not good, and it was a really difficult process to make them good. So it was to make it easier, basically.
Yeah, thanks. I understand. I mean, there is some use case behind it, but it's probably, I mean, it's a challenge to validate or something if you want to do that later. But yeah, okay, thanks.
Yes.
Well, I have a question. If there aren't
before your question, Helena, there was a question just asking if we have further developed to other platform. We started Urge first in Figshare. We developed for Figshare. We moved to Dataverse NO this year. Before we were using Figshare, but we developed it first for Figshare. Then when we moved to Dataverse NO, we further developed to Dataverse NO. Of course, we will develop to other platforms also. We'll let you know.
Yes.
Good.
And of course, we have plans to develop it to make it possible to import from other sources. So there was a question about too. Yes. Sorry, Helena.
No, I'm sorry. Didn't mean to interrupt. I just have one final question if there aren't any others. Of course, we also experience challenges when it comes to README files because it requires some training and understanding in order to achieve that level where you know how to write a good good README file. But I'm just wondering, and I have no idea about the answer. I'm just wondering, so if having this tool where things can be more automated, where they don't do we then run the risk of researchers thinking, well, I don't have to do anything more, and I don't have to learn like the basics of writing good README files so that they are less prepared to evaluate what comes out of the tool?
Yeah.
So I'm just asking the question. Yes.
It's a really good question, and I've actually asked myself that question because that might be a risk. So I think there is a challenge for us to communicate that it's a tool. It's something that is supposed to help you kind of to get started, to help you along the way. But of course, it does not deliver a finished project. It delivers kind of a basis for the researcher to work further on. I think we have to be clear on that it can give you perhaps a fundament for an easier fundament, kind of an easier start to write, because I've asked myself that myself, and we must not, of course, forget the importance of the writing part of it, of course, and the evaluate.
I think it's very
can I supplement? I agree with you, Helena. But on the other side, we, for example, we say that one of the advantage of writing a data management plan is just it will save our time later on when it's time to share our data or to archive our data. So it shows, for example, if one has developed good data management, updated data management, one can just import it. So it shows the importance of having a good data management early in the project also.
Yeah, thank you. It's a very good point. Good. Philip, do you have one final short comment or question?
No, it's just to support what Ahmed, what Ali and Dag said. So I mean, they don't get things for free. They still need to formulate the text. It's just kind of, it helps them to structure in a Ruby file. And if you already have put your metadata into the repository or as in a DMP, then I mean, it's just helping you to reuse that information.
Yes.
But as I put in the chat, I would also see supporting the other way around, so that if you start a README file way before you think about depositing, then you should be able to extract the information from the README file and then put it into the metadata scheme of the repository.
Thank you, Philip.
Thank you. Okay. Do we have? Yeah, we have time for a very short comment or question from Alan before we go to the break.
Okay, yeah, it's break. Yeah, I just wanted to ask something about reading files, but I can follow up with Philip.
Okay.
Yeah.
Okay.
Thank you. No
Okay,
problem.
so then I think we will have 3 minutes comfort break. So we will reconvene at 14:50 for the final talk of today. So thanks again to Doug, Evan, and Ali for giving the presentation about Urge. Thank you very much.
Thank you.
Thank you.
So
Thank you.
see you again in 3 minutes.
Hand over to Alan Vodopievitz. Hopefully I didn't murder your name too much, who is head of information and technology at CESDA. And he will be talking about citation and reuse and how to track data impact with APIs. So I will hand over to you.
Thank you. Just a sec to find the window. Okay, this is okay. Okay, can you see the full screen now?
Yeah, looks good.
Okay, so yeah, we are 2 speakers. So because Kostas from CESDA service provider Eke from Greece is with us because he developed the app that we use for this tracking data impact. So in this presentation, we will talk a bit about of motivation for tracking the PID, this PID to PID relationships, overview of the API thing and APIs for publication citation tracking, and some of our use case examples and results of this pilot that we let's say conducted. So why we get there? So why to track publication data citations? We each year at CESDA. So CESDA is a consortium of European social science data archives. We have main office here in Norway, and we have service providers, our members. Our members are practically European countries with a representative in each country. So national social science data archives is a representative, and they are our service providers. And each year they provide also some numbers about some kind of key performance indicators and number of publications related to data sets from their repositories is one of the numbers. During the years, this number changes, and each service provider has a bit different methodology, you know, and the way how to collect these numbers. And so practically this is not comparable. What we wanted to achieve is to organize and structure a bit this collection. And of course, the idea is to make the whole process some kind of automatic, and to use the PID to PID relationships, which could be tracked online using available services and platforms. So, and we would like to encourage data citation, later use, yeah, and to, let's say, somehow enhance this culture of citing data sets. So there were two things: manual. Some of our service providers use these manual methods using Google Scholar or some other platforms. And as I already said, it was inconsistent and of course time consuming. The other thing is API-based tracking. So we identified several platforms like OpenAlex, Crossref, Open Citations, OpenAir, etc. So we wanted to see, is it how we can what numbers can we get, and can we compare this to? So all these platforms use the API. API is some kind of programmable interface. It enables I put here rule-based information exchange between software applications. And for example, you have these payment applications, and also one of the example is this exchange of metadata and scholarly data APIs. So we used as a source of data sets, we used our CESDA data catalog. So this is the aggregator. We are harvesting all repositories of our service providers and have central metadata catalog of these studies. So we extract all DOIs from these studies from CESDA data catalog, and we ran one script to harvest citation counts, searching for these PIDs, these DOIs in different platforms. So we used here Crossref, DataCite, EuroPMC. Kostas, you will, yeah.
These are the ones. Hi, Alan. Hi, everyone. These are the ones that will be tested or may be tested. The three latest are the ones that we used.
Yeah, okay. OpenAlex, Open Citation, and Semantic Scholar is the ones that we collected information in a structured way. Technologies used were TypeScript and some standard technologies. And as I already said, OpenAlex, Open Citation, Semantic Scholar. Request was how many publications we can find. So this PID to PID connections in these platforms. And in the response, we tried to get some more metadata and bibliographic information for these for records that we find. So this is example. We have some of our service providers. Each of them have their DOI prefix and the records, DOIs of the records. First, I mean, we also wanted to compare, we had one Excel file with manually collected publications from one of our service providers. So we wanted to compare this with automatically, collected and extracted information, and to see if we can be better, if there are some gaps, or what we will get in the end. So we try to automate this process of collection and export and compare the final results. So, Kostas, would you like to take over?
Thank
and
you.
explain, the process a bit more in detail?
Yes, thank you so much, Alan. Hello, everyone. So as Alan initially said, the initial idea was to first compare against a manual Excel file. So imagine there may be a web version of this or not, that many people are actually typing the citations that they may find about a DOI, a particular DOI that they're interested in. So they were collecting their findings in the Excel file. And of course, there may be duplicates in that Excel file. So maybe someone typed something a bit different from the other person. So in that sense, when we first began the development, we needed to carefully handle an Excel file and the findings that we can get from there. So there was a structure input, and it still works. The structure is, as you can see that in the screenshot, the publication title, authors, type, year. The DOI citing is the DOI that the original DOI is actually citing. So column F is the original DOI, the one that we're testing, and the DOI citing is the finding that we will get. We then parse this Excel file to the inputs, and the script will auto apply single acceptable DOI structure for all records. So meaning if you see column F in detail, these 5 records will be treated as one DOI. It's actually one DOI, and the program will treat them as such, and they will be merged. Next slide, please. So after the Excel parsing, what we did was we gathered the studies from the CESDA data catalog. So CESDA data catalog acts as an aggregator, collecting different studies from the service providers, as Alan previously explained. So what we did here was we gathered all up-to-date CDC, CESDA data catalog records, by accessing CESDA Elasticsearch data store. This is where actually the metadata. We made some Elasticsearch queries modified to fetch distinct records, because a study might live in the CESDA data catalog in different languages. That means multiple DOIs. So we wanted to ignore that and treat the DOI as a single record. The study details that we fetched are the PID studies, title study, creators, publication year, and code of the service provider in order to track the KPI impact, as Alan said. Then when we gather all these results, we can begin the assessing process for the return results that I will describe to you in the next slide, please. So this is the first API. This is how we use the OpenAlex API. So we do that in 2 steps. So the first API call is the one to get the citations for the input DOI. So this is the DOI that we're trying to gather what sightings it may have, and this is the URL. It's a get HTTP. So the number of citations would be recorded inside the byte count. If that number is bigger than 0, then the code would also return a cited by API URL in the response, as you can see that in the bottom right screen. So the bottom right screen, the cited by API URL returns the URL, and this one has the internal ID that OpenAlex likes to give to the studies that it has. It uses its own ID. So then we get that URL, and then in the next slide, please. And then in the next URL, when we use that when we use that URL, then we can get the results as you can see in the bottom screen. And the results include the DOI, the title, the publication date, language, type, authorships, institutions, keywords, etc., etc. These are some of the information that return for the results of this particular DOI. Next slide, please. So after OpenAlex, then we begin accessing for the Open Citations API. And this one, again, involves two HTTP GET requests to gather the information that we're after. So the first API call to get citations for the input DOI is the following, and you can use that as well from your browser. If citations are found, then we create a new request per citation to obtain metadata. And this is the tricky part for Open Citation. So you can see that it's actually in some of the results in the screenshot, you can see the DOI included there, as well with OpenAlex internal ID. You can use that as well. But as you can see in the next slide, please. We got the DOI from the previous screen results, and then we collect the DOIs, which also include the citing. And this is you can see that in that screenshot below. We use this API to get the results for the citing. Includes also including ID, title, author, publication date, issue, volume, venue, etc., etc. Next slide, please. And finally, for the Semantic Scholar API, it's simpler than the previous two because we just use a single API call to obtain all relevant data for the DOI that we're trying to see if it has any citations. The parameters field that may be of interest can be set along with DOI in the HTTP GET request. So this URL actually with just one URL, you get all the relevant information that you're after for this particular DOI, and you can use that from your browser as well. Next slide, please. This is just a screenshot featuring the results for when we use that URL of the API, and you can see it also includes the ID and internal ID that they have, the DOI, also title, year, publication type, the authors, etc., etc. Next slide, please. This is some more technical details about how we gather the results. We created some custom types, some custom interfaces. We call them publication info, and it contains these fields. And then the final one, when we gather all the results, and remove duplicates, etc., is the one called publication final. Then we organize the results obtained from input Excel file or APIs to publication collection. And after data cleanup, we organize complete results to publication final. We parse the results, and then finally we export them to a nice CSV. Next slide, please. So some pilot results from the API test that we performed. The runtime for the input Excel file was about 2 minutes per 100 DOIs input with all three API tools tested: OpenAlex, Open Citations, Semantic Scholar. A CSV result file following the publication final interface structure with information on the DOI that we accessed, the array of JSON items obtained from the original file, and the data catalog and APIs, the count of the results obtained from each API source, and also total count of results obtained from all API sources while eliminating duplicates, so we know we have the correct numbers. Yeah. And here's one interesting test that we performed. We tested for this DOI in January last year. Yeah, and for an input file of Excel, which had like 17 records that may or may not be duplicate. The OpenAlex found 8 results, Open Citation got 4, Semantic Scholar got 5, and then with our tool, the unique findings for this DOI was 11. Then we rerun the assessing 10 months after, in October, and we see that we got 2 new findings from the API tools, while no changes have been made to the original Excel file by manual findings. So this is interesting because we can see that with the API tools, we can also pick new results, new citations, and have them ready to be analyzed. Thanks. Next slide, please. Back to you, Alan, for some key takeaways.
Yeah. Okay. Thanks, Kostas, for this. Yeah. So this is some kind of pilot that we tried to see what numbers we would get. So I think it was pretty successful. We can see that we can automate this tracking, but the results are also inaccurate because we can see across different platforms we are getting different numbers. But yeah, we will try to include even more platforms, and the next step will be to explore the School Explorer. This is the service from OpenAir, I think, and they say that they collect information from all these and more services, and from some commercial services like commercial publishers like VOS, Scopus, etc. And they are building the database of all PID to PID links. And then, of course, as we saw, tracking PID to PID is one thing, and then getting the information, the whole bibliographic information is usually it's the second request that we have to run. So yeah, we also see that data citation practices are almost yeah, we can say immature. In some cases, there is no proper data citation practice, and yeah, metadata may be incomplete. Next steps will be combine even more these APIs. We will try to get some additional information like citation counts from Scopus and yeah, some other platforms, and to build a bibliography of CESDA from publications based on CESDA dataset found in CESDA data catalog. So we can also enrich records in CESDA data catalog with this information. And this is also, I mean, it's useful also for researchers to find related research, you know, to get some other ideas, and maybe to find some researchers that are in the same, let's say, field of research as they are. What we also saw as some kind of drawback here, this PID to PID links. First, you usually don't know exactly if PID to PID is dataset to dataset or dataset to publication. And then if it's dataset to dataset, you are not sure if this is like a combined dataset. So some new dataset that is based on the source, or it's just the same dataset, just reused and re-referenced again. If it's publication related to this dataset, you don't know if this is like an original analysis report, or is it also some kind of reuse, or the analysis, some different analysis of datasets. So is it real reuse? So we are lacking metadata information in that sense, and I'm not sure, maybe we can have a discussion about that. Do we have this information? Can we track this information in current metadata schemas? And if not, what can we do about that? And what do you think about this current data citation practices? And do you have any experiences with that? So these are my questions to you, but you can also, of course, ask Kostas and me. Thank you.
That's great. Thank you very much. Does anybody have any questions for Alan or Kostas at this point? Just going to check to see if there's any hands up. I don't see any hands yet, but I maybe will kick it off, and maybe other people can follow in. So it's really interesting to see the pilots, and I was just wondering, like at the moment, it seems like you're able to make use of the DOIs to track the publication citations. And I was just wondering, in the information that you get back, is there any way from that information that you can look at things like grant IDs or funder references? Like, I'm just trying to understand if this kind of impact information could be used to help understand, the impact at that level as well, or is that something that's beyond the scope of the pilot?
That was out of scope. I mean, in this first step, but in this next step of building a bibliography, this is important. Usually, we don't get this detailed information, but I hope that we will get this through OpenAir, thing. So to get PID to PID connections through Scholar Explorer, and then to search for these records in OpenAir, and OpenAir has very detailed, usually detailed metadata description with grants and access information, etc., etc. It's not perfect, but it's way better than these services that has just a basic metadata descriptions.
Oh, great. Thank you. I see there is a question from Lauren, just asking about the OpenAir PID graph. Why do you think you saw the difference across the APIs, she's asking? Do you have any sense of why there was differences?
Why there are differences? Because, I mean, they probably have different sources that they are building their databases or graphs. OpenAlex is Kostas, a Microsoft thing from this academic graph, I think. Yeah.
Yeah, I came before. I came after. Yeah.
I think, yeah. Open Citations, they harvest their information somewhere else, etc., etc. So, yeah, the key is to try to combine, and also this Scholar Explorer is doing the same thing, but also they are doing deduplication. And one more thing now I'm promoting the OpenAir, but I'm really not sure if we can get this kind of information. But they are stating that they are mining, these PDFs that they have in all harvested from the repositories, and to extract, let's say, grant information and PIDs and that are somewhere in text. because as I said, data citation practices to properly cite the dataset object, they are not in place, and people sometimes said, "Oh, I use this dataset. You can find it here, there, in some kind of acknowledgement, etc." So you can get this information just with some kind of data mining, and we will test if really we can get this through OpenAir. But we will always get different information because, yeah, the systems work differently. And did you consider OpenAir PID graph? Yeah. This is that's the idea. But I got the information that this Call Explorer has more covers more different platforms that they harvest, and then when you get PID to PID, when you get the connection and unique identifier for this related publication, etc. And then you go to the OpenAir graph and get the detailed information with everything that you have with, I don't know, grants, people, institutions, etc.
Great. I don't see any other hands at the moment or anything else in the chat. Sorry, Lauren, I don't know if you do want to unmute and ask your question.
Sure. So I was just going to say a colleague of mine, Philippe Guérin, who he runs a large data repository in the infectious disease space. They did a study where they looked at data sharing statements. And oftentimes when people say in text, "Oh, I'm going to make my data available in so and so repository," if you go to the repository, it's not there. So I think depending mining, I mean, there's one thing if you're mining text statements for numbers or the DOI or something, but if you're just mining for the statements, then you really have to follow up because often they're just not true.
Yeah, I totally agree. So we are trying to get this PID to PID links. Next step would be, as you said, to check if the PID really exists. So now we have, I mean, in general, when we look the overall numbers, we have much lower number that we got through this automatic collection than we get through the manual reporting. But I hope that with let's say encouraging researchers and educating them about data citation, etc., we will get these numbers higher. But we will stick with PID to PID connections, not just text statements or something else. We will try to be as much how to say? I lost the word. Okay.
I think you've answered your question anyway. I saw the thumbs up, so that's great. Any final questions for any of our speakers for this afternoon? Okay, I think everybody's feeling a little bit tired by this point now. So we just have a couple of very brief final slides just to share. So first of all, thank you to all of our speakers from today's 3 sessions and specifically for this session today. It was really interesting to hear about all the work going on. We hope you found something useful today to help you to maybe go back and delve into in a little bit more detail. Obviously, you have the information provided in the links, and please feel free to reach out to anybody that you've heard from today if you're looking to get a little bit more information. We certainly will try to get all of this stuff wrapped up and put on the website, hopefully by the end of this week if we're lucky, but it might well go into early next week before we can get them all uploaded, but they will certainly all be available in case you want to come back and recheck anything in case you missed something, and we'll be in touch with the details on that when it's ready. So just one last kind of slide from us. It's just, if you are interested in keeping up to date with the work of the Fidelis project, we're certainly keen to have you come along with us over the next few years. There's a couple of points here I'd just like to raise. One of them, if you're not already part of the provisional Trustworthy Digital Repository Network, please take a look and consider joining. It is very much in the early stages. We currently have 63 repositories, but we're always happy to have more people join. So take a look at that and join maybe some of the sessions to learn more about that. As I mentioned before, we have some open calls coming up to do some practical adoption of solutions and also for mentoring and peer-to-peer support. So please keep an eye out for those calls coming out, and please do consider applying. I think the people in the room are exactly the kind of people we're hoping to engage with these open calls. And finally, just to say, we do have a newsletter. So if you are finding it difficult to keep track, you can subscribe to the newsletter and you'll get automatically updated every so often on things that are happening. But with that, again, just thank you to everybody for taking the time today. We know it's been a long day for many of you if you joined more than one session. So thank you for giving up your time. We hope that you found it useful. And please do keep in touch with us and with each other. So enjoy the rest of your day. Thank you.